Hello, in this video we will look at diode reverse biasing. In my last video we saw that a forward bias diode acts like a one-way valve and current flows through the one way. Over here now we are going to reverse bias the diode, which means it's still positive, that the polarity of the cathode, that's the line, is positive with respect to the anode. Okay? So that means then the voltage on the anode which is 12 volts, is on the cathode, sorry. That's why we have erasers. Voltage on the cathode is greater than the voltage on the anode, okay? Notice when you reverse bias it, that this depletion region has greatly increased in width. And that makes it very difficult for the electrons to move from the cathode to the anode. And so that means then that the resistance between these two regions is essentially infinite. It's not quite true, but it's very large. Okay? So if the resistance anode to cathode is very high, you may think of the diode as being like an open switch. Okay? If you were to look at this more technically, we would put a high value resistance in parallel with that switch to represent the dynamic resistance between the anode to cathode. So what that means is a diode reverse biased acts like an open switch with a high value resistor between them. Okay, so it really isn't infinite. So that means then there's a current path through the diode, but because that resistance is so large, this current, which is termed the reverse leakage current, is going to be down in the microamp range, and it's ideally but not exactly zero. If that's the case, then we have no current flowing through the resistor. By Ohm's law, then this voltage here must be zero. So Kirchhoff's law demands that the voltage be somewhere, so all the source voltage is across there. Okay. In reality, this voltage on the diode is probably 11.99899. That's because of this resistor, and this voltage on the resistor is probably like 0.1, 0.2, something like that. Okay. So a reverse bias diode has a wide depletion region. The current is ideally equal to zero. Thank you for watching.